Hello everyone, and thank you for joining me in this session on TypeScript. My name is Sander Mak, and I don't like JavaScript. So there, I said it. I don't know if there are any people here who feel the same way. Yeah, some more. Great. So I like the idea of JavaScript being a very widely available environment, and people are doing great things with it. It's just that, yeah, the language itself really feels like it doesn't give me enough as a developer. So with the advent of single-page applications, HTML5, etc., yeah, JavaScript has become a necessity almost for us in our projects, and we used it a lot. Until at one time I stumbled across TypeScript, and I think it's a very, very nice alternative to JavaScript, while being in the same ecosystem as JavaScript. And hopefully this talk will help you see what TypeScript can do for you. So I'm going to be talking a bit about why we chose TypeScript first, and then I'll do a little bit of live coding as well, just to show what the language can do for you. And yeah, if you have any questions, just feel free to ask, and we'll address that directly. So if you ask me what is wrong with JavaScript, you could create a fairly long list. There's this popular book, JavaScript, The Good Parts, which is really small, and you have this JavaScript, the definitive guide, which is really big. So there's lots of things to talk about when you talk about the problems with JavaScript. But for us, the main thing was that, yeah, it is a dynamically typed language, and we, as a company, are mainly Java developers who also have to do a bit of on the front end, and it's a completely different world, completely different way of thinking when you are coding in a dynamically typed language. Another big part is that JavaScript as a language doesn't really offer many constructs to really modularize your application. So what you need is some form of information hiding, maybe some form of creating interfaces between components to do really modular development and to scale your development efforts. That's really something that you cannot quite do with JavaScript itself. There are all kinds of ways to work around this, and there are lots of patterns that you can use, module patterns for JavaScript, and there's also a pattern called iffy, for example, immediately invoked function expression, which is a sort of a trick to hide information inside this function expression, because the function scope is the only scope you sort of get in JavaScript. But these are all workarounds and really not nice to work with. So, and I would say if your language has patterns which are called iffy, then, well, something's up, right? So that's when we decided, okay, JavaScript, I mean, we're going to need it. We need it for our HTML5 single-page applications, but development doesn't scale in the same way as we are accustomed in the Java language or any other server-side language that you might use. Still, there are a lot of good things about JavaScript itself. When looking at alternatives, it's easy to come across alternatives that completely break with the existing JavaScript ecosystem. And in my opinion, that's really a bad move. I mean, there's so many libraries, there's so many runtime environments, Node.js, the browsers, etc. And yeah, just throwing that all away is really a non-starter. So in this way, we really said we'd like an alternative language, but it really has to be part of the JavaScript ecosystem. It has to be able to integrate with JavaScript itself. And in the earlier slide, I said dynamic typing is sort of bad, and in some ways, I still think that's the case. On the other hand, if you create UIs, then some form of dynamic typing can make your life a lot easier as well. So we all know the pain of creating Swing GUI applications and doing that by hand. Really, some form of dynamic typing really helps cut down code in the front end as well. So there's a trade-off here, and I think you'll have to make your own choice in this regard. So what we did is we sat down and we thought a little bit about, okay, what is it that we actually want in an alternative language to JavaScript? So for us, it was all about creating a more scalable process, having a language that enables scalable development in the same way that Java does for us on the server side. And I already talked a little bit about modularity, which is, in our opinion, quite important if you want to scale your development process. So the language would need to have some sort of constructs to actually promote information hiding, promote clear interfaces between components, etc. On the other hand, it also has to be something that's moderately easy to pick up by people who already know, for example, Java. You can, of course, switch to some esoteric functional language and go all the way to something very, very concise and maybe productive for some people, but it has to be easily digestible for mainstream developers as well. Also, when looking at alternative languages in the JavaScript ecosystem, it's really important to think about how much do you tie yourself to the implementer of this language, to the implementer of this alternative. For example, if you're going to use Dart, then you tie yourself to a compiler that is developed by Google. But not just that, and it's not just compile time, but at runtime you also need the Dart library, which is sort of huge. And you have to include it with your application. And sometimes that's a good trade-off, but in our opinion, in a general sense, that's not really what we want. So we want to have a language that has both a long-term vision and backing, but also is quite non-invasive in the sense that we can still keep on using some of the libraries and tools that we already have in JavaScript. And of course, this rules out any really locked-in platforms like Flash or whatever you have in those areas. And what I really like about compiled to JS languages is that if they compile their language to JavaScript, like Typescript does, that you get really clean output, so that you can still follow it and still be confident that you know what's going on in the compiler and what's going on when your code is output. This also means that you have some form of an exit strategy. In our case, if we were to ditch Typescript, we can do that. We can just stop using the compiler and take the output at a single point in time and have a fairly idiomatic JavaScript code base that we can start on working with. So we don't do that because we like TypeScript, but in theory, we could definitely do that. So it shouldn't really surprise you that for us, TypeScript really ticked off all the marks on this wish list. And in the remainder of the talk, I'll show some examples and show you what features TypeScript actually offers to help us achieve these goals. So first, let's get this out of the way. Yes, TypeScript is a Microsoft technology, formerly known as the Evil Empire. However, it is fully open source. It is actually Apache 2 licensed, the compiler and everything, all the tooling around it as well. It's on GitHub. It's freely accessible for anyone. And if you look at the activity, I mean, there's lots of collaboration. There's a very large community currently forming around TypeScript. So that's really a nice step forward for Microsoft itself and also for the users of TypeScript. And the compiler is hosted as a npm package as well. So if you have Node installed on your machine, you can easily just install the compiler and start using it. One thing I really like is that the language is not designed by just anyone, but this guy, Anders Helsberg, who was also responsible for designing C#, amongst other languages, is the lead engineer on this project. And I really trust his vision and trust his choices that he makes for the language. So that's really cool to see. So what is TypeScript? If you look at the language itself, you will see that it's actually a superset of JavaScript, which means that if you have an existing project and you want to convert it to TypeScript, well, then you're already done because valid JavaScript is also valid TypeScript. But, of course, you want to do more than that. So it also offers an optional type system, and I'll show some examples of that later, but it means that you can effectively use the type system when you want to, and you can ignore the type system if you want to as well. And obviously, there's a trade-off there in how you want to approach this, but it's all up to you how far you want to go with this. In the end, it compiles down to just plain ES3 or ES5 JavaScript code, depending on your compiler flag. And there's even support for ECMAScript 6, the recent version of JavaScript that's just been finalized last month, or even this month, I believe. And the nice thing is, once you have compiled your TypeScript code to JavaScript, you don't need to include any runtime library anymore for your application to run. It's all just plain JavaScript. So the 1.0 version was shipped in April of last year. And since then, they've rapidly been iterating on the language and on the compiler. So there's a few releases already after that, and we're currently at 1.5. And another thing that I really like about TypeScript is that in their sort of mission statement, they say that all the features that they are going to implement will be features that are part of the JavaScript Next specifications. So in this case, TypeScript does, for example, support classes, and for that it uses the syntax that has been defined in ES6. So that actually means that you can use today features of the next version of JavaScript without relying on browsers having already implementations for this next version of JavaScript. So in this sense, you really can work in advance and get new features more quickly than if you would have to wait for all browsers to support a new version of JavaScript. So I would summarize this as TypeScript for us has been very, very lightweight in terms of how difficult it was to integrate, and it really did give a productivity boost to our front-end development. So how do you get started? I already told that the compiler can be installed as a node package. So in this case, you just do an npm install -g TypeScript. And what you can do is you can just rename your existing JavaScript file to .ts TypeScript file, and then invoke the compiler on this file. And this will cause the compiler to do absolutely nothing in terms of code transformation, because valid JavaScript is valid TypeScript, but it will be the same output. But it will be able to already give you some problems and show you some problems that might be in the code. So in that sense, it's sort of similar to doing JavaScript linting, like the checking tools that you have for JavaScript. If you use it in this way, then TypeScript is sort of similar to that. So a little example of the optional typing is in order. So when you would have a JavaScript file with a variable a, and you assign it the integer 1, 2, 3, and then you call a.trim, which only exists on strings, so that's not going to work, obviously, but you only find out at runtime, right? And that might be hidden somewhere in a code path that is triggered very infrequently, or you didn't test it, and it blows up at runtime, and it's not good. So what happens is that in TypeScript, you have the option of assigning a type to your variable. And in this case, you say, okay, I want the variable a to be of type string, and you accidentally assign 1, 2, 3 without the quotations marks. And the TypeScript compiler, upon compiling this file, will tell you, okay, I cannot convert number to type string, so there you have it. At compile time, you already have detected the problem instead of at runtime. And you might be wondering, okay, do I have to annotate types everywhere then, if I'm going to use TypeScript? Well, fortunately not. The compiler is so smart that it can also infer types for you based on the literal values that are in the code. So in this case, if you would leave off the string annotation, you would get the following. You will get a variable a to which you assign 1, 2, 3, which is of type number, and the compiler infers that. And then you get in the next line, you get a trim call on something that is of type number. That is what the compiler inferred for you. And the compiler will complain, okay, there's no trim on a number. That's only available on strings. So this is a very small example. I'll do a bit of a bigger example later as well, but it really shows you already that you can catch errors at runtime, at compile time, that you would otherwise miss in JavaScript. Now, one question that a lot of people ask is, okay, what does this mean from a performance perspective? Do these type annotations or these types influence my actual code at runtime? And that's not the case. The type checking is really a compile time affair. So once the code is compiled, there's no notion of types anymore in the compiled code. It will just plain JavaScript without any additional checks. So let's try and see if we can get a little bit of a bigger demo going. And for that, I'm going to go to the TypeScript website, and they have a so-called TypeScript Playground, where you can even try and code TypeScript without installing the compiler on your system. Since the TypeScript compiler itself is written in TypeScript, it can be compiled to JavaScript, so it can run in the browser, and that's actually what they did here on the TypeScript side. So I'm going to get a little bigger example up here. And just to walk you through it quickly, we have a plain JavaScript blob, which is valid TypeScript, so it compiles to exactly the same code modulo some formatting that the compiler does. And in this JavaScript, we have an array with objects that have a name and an extension, so fairly simple. And we have 3 elements in this array of languages. And we coded a function findByName, which, given a name and some elements, tries to find the right object in this list of elements, given the name. And we wanted to match regardless of the case. So it has to be case insensitive. So I'm not going to ask you to try and spot the error, because there's an error in here. What I want to show you is that I'm going to use this editor. And as you can see, it already has a form of auto-completion, which also uses the TypeScript compiler tooling underneath to do this for me. And I'm going to call this function, and I'm going to call it with, for example, Java. And as you can see, the squiggly red line complains already, okay, you're trying to call findByName, but you only supplied one of the 2 parameters. Now in JavaScript, this is a valid thing to do. You can do that. And if you do that, it will call this findByName function with the first parameter and setting the second parameter to undefined, which is rarely what you want. So in TypeScript, they have arity checking on methods that is stricter than what is allowed in JavaScript. So you can fix this by saying, okay, I can make this an optional element, and then you have appeased the compiler, and you have explicitly said, okay, this might be an omitted parameter. But in this case, that's not really what we want. We need elements to find our language object. So we're going to pass in languages as well, and we're going to run this code and see what it does. And as you might expect, there's some runtime error here. It says, okay, I cannot read a property of toLower of undefined, whatever, not very helpful. So what I'm going to do is I'm going to introduce types into this JavaScript code and see if it can help me find the error. So in this case, I'm going to say, okay, I know that at least the elements has to be an array of, well, I don't know really what yet exactly. So you have the any type, which is sort of like object in Java. It matches all instances, all values. So I can say elements is of type any array of anything. And it already finds an error for me. It says, okay, there's no name property on something of type number. And I was expecting the value to be something that comes out of the elements array instead of being a number. So somehow a value is of type number. And why is this? Well, let's look at for each. And again, I get this nice help because it knows about the type of elements. So it knows there's a for each method on this. This is a standard JavaScript method on arrays. And it gives me the type signature for this function. It says, okay, I have a callback function, value of type any, and index of type number. Okay, so I switched the parameters here. I made a mistake. So I don't get the index as the first value in the callback, but I get the index as the second value. So there we go. Let's do it like this. And okay, it doesn't complain anymore. So let's try it again. Let's see what happens. And still, we get a runtime error. So we're not being precise enough yet in the type annotations, in the extra information that we put into the code. Somehow, something still goes wrong at runtime. So there's an uncut type error. Undefined is not a function, which again is really not very helpful. So let's try and see if we can make our type annotation more precise. So one thing that TypeScript also has is the concept of interfaces. So what if we could define an interface for the shape of these objects, and we could use that as a type annotation? Let's try and do that. So I say I want to make an interface language, and it consists of a name field with type string, and it consists of an extend extension field also of type string. And you might wonder, okay, interfaces, somehow something has to implement an interface. In Java, we need to explicitly declare that classes, for example, implement interfaces. So how does it work in TypeScript? Well, it works fairly easy. We can now say that elements is of type of a language array, and it will actually know and see that these objects conform to this interface. And this is a structural match, so we don't have to care about the name and have to explicitly say, okay, this object implements language. No, the compiler can see that the shape of this object conforms to this interface, so it knows that we are allowed to pass this array of these objects into the findByName function, which has this type. Now, this brought to our attention a different error. In this case, it says, okay, the toLower doesn't exist on a string, which is very nice because the value that we got in here now has a type language, because we changed any array to language array, and it knows that this language has a property name of type string, and then it can say to us, okay, there's no toLower on string. Well, probably we made some error there, so let's try and see if we can find the right method. And again, TypeScript, the tooling around it can help us because it knows about everything that's allowed to be called on strings. In this case, we can see that there's a toLowerCase method instead of toLower, and we have to call that. So just to quickly show that there's another error as well, we say, okay, name has to be of type string as well, and then it finds the same error in the name argument. So let's change that to toLowerCase as well. And the compiler is happy, and we can try and see if we can append our results to the document. So as you can see, the TypeScript compiler also knows about some of the global objects that are available in JavaScript. So in this case, it knows that there's something called document that's always available in your JavaScript environment of type document, and it has a property body and inner HTML. And we're going to set it to the JSON result. JSON is not a built-in object of JavaScript runtimes. We're going to stringify the result, and it will be added to the document. So hopefully, if we run this, we will see indeed this Java object being returned from the function. So in this demo, we've seen that we go from plain JavaScript to sprinkling in some small annotations, some small type annotations, which help us find real bugs in the code. And as you can see, this isn't really about reducing the number of lines of code or being in a completely different type of language. It's more about taking JavaScript and powercharging it by bolting on this type system. So are there any questions about this so far, before we continue?
In your declaration, I noticed on the TypeScript side, you don't terminate it with a semicolon. It seems to be inserted. Is that something that just TypeScript does?
Yeah, so the question is, I'm not inserting any semicolons, and the compiler does do this for me. If you write JavaScript, it's sort of recommended to insert semicolons. Same for TypeScript, you can omit them, but it's recommended to still use them like you would in JavaScript. But if you don't, it will output them at the locations the compiler thinks where they belong. So,
okay.
Yeah.
And the second question is, so when you declare languages, you're not saying that it is, implements the interface language as its structure. And so when you're using it in that function call, it's just simply looking at the shape of that structure to see if it's compatible with language?
Right, so indeed, if you use a interface as type, then the objects in the array must conform to this signature. And you can even have multiple interfaces with the same signature, and then they conform to all. So you can use any of these interfaces then. There's another question?
Can you say that the language is variable matches that interface, or text automated?
I'm not sure I quite follow the question. Can you repeat it?
Can you put the language type on the languages?
Okay, so the question is, can I put the type on a different place as well? Can I say explicitly this is of type language array? And yes, you can. And you can see also that if I would remove one of these, it will actually complain about the fact that this is not a language because it misses the extension. Now we can, again, solve this by making it optional, right? So we know that we might or might not have an extension, but yeah. Okay. Then we're moving on. So what do we use interfaces for? Well, we use them a lot also to describe, for example, the return values that we get from REST calls in our front ends. So if we do a get to a user endpoint for some user, then we have a TypeScript interface defined that tells us what the result will look like, what the JSON result will look like. And effectively, this is sort of a cast, because you cannot really, at compile time, know and enforce what the shape is of a HTTP call result. But still, it's helpful in development to have an interface for this return type. And if it doesn't match at runtime, then you will just run into the type errors like you would normally with JavaScript as well. So it's also possible to switch a compiler flag, which is called no implicit any, to force you to annotate as much as possible. So it won't allow the any type to be inferred. So what does this mean? It means that if you have a variable, in this case it's called ambiguous type, and you first assign it a number, and you then, at some later point in the code, assign it a string value, if you don't have this compiler flag on, then this is just valid TypeScript as well. It's just that the inferred type of ambiguous type will be any, and it's really not useful. So what happens if you do this, switch this compiler flag to no implicit any, is that it will say, okay, you probably made a mistake. You have a variable, and you assign two things of different types to this variable, and probably that's not what you meant. So you can fix this in two ways, either by removing one of the assignments and saying, okay, that was a bug, I needed to do something else, or by saying, okay, this is really what I mean, so I'm going to put a any type annotation on the ambiguous type. So I'm explicitly saying to the compiler, yes, this is really what I want this dynamic behavior for this variable. So of course, the ultimate way to use TypeScript is to have this enabled for your complete code base and to have a full type checking going on for your whole code base. But it's not really feasible to do this when you're migrating existing large code bases directly. It will be an incremental process. So there's a question?
Could you type that as number and then retype it as string later, or would it have to be any?
The question is whether you can type it first the same variable as a number and then later a string. I haven't tried it, but I would be highly surprised if it's allowed by the compiler. In fact, let's try it in the playground so we can all find out together. So we have a variable ambiguous type of type number. We say amp type is 2. And then we're going to redefine it. And I really hope that it will complain and shout. And it does. It says subsequent variable declarations must have the same type. So there's your answer. Yeah. So where there's interfaces, you probably already expect that there's classes, and you're right. TypeScript does offer support for classes. In some ways, it's similar to classes you have in Java. In other ways, it's different. So what is the same is that you can actually implement interfaces using classes. And you don't have to do this, because we saw that there's a structural matching going on as well. But if you do this, if you say explicitly this class must implement this interface, then the compiler will also shout at you if you forget something from this interface. So that's the difference. So a class can implement interfaces. There's inheritance possible between classes, single inheritance. There's you can have methods and members on classes like you have in Java. And you even have statics that you can use. So what's different? In TypeScript classes, you only have a single constructor available instead of overloaded constructors that you can have in Java. Not really tied to classes, but you have default and optional parameters. Well, we've already seen the optional parameters with the question mark. What you can also do is assign default values already in the declaration of the parameter, which effectively also makes it optional. And if you leave it out, it will get the default value. And like I said, TypeScript is aligning with ES6, so the next version of JavaScript. So this class syntax that they adopted is exactly the same as will be in the next version of JavaScript. There's a question. Yeah.
Is there out in the TypeScript language to enable you to add dynamically properties and functions to a class, for a particular instance?
Okay, so the question is, can you still circumvent the whole static class definition and add properties and methods later? And you can do that by using the property access syntax. So let me quickly switch to the playground again to illustrate it with an example. If you have an object in JavaScript, so I have an object of t I, and you can access it like this, but you can also access it like this. And if you use this notation, then you're fully in a dynamic world, and you won't get any type checkings, because if I say, okay, object.f, it will happily do this at runtime and give me undefined. Whereas if I would do object.f with this notation, it will complain there's no f on this object. And the same happens for classes. Yeah. So since we're here, I was going to show you classes anyway, so let's do that. And I'm not sure why the rendering is sort of weird, so let me try and reload this. Okay, there we go. So we have a very, very simple class definition, which is class concert, and it has two members, artist of type string and tickets of type number. And as you can see, it compiles to a fairly well-known pattern in JavaScript, which is a form of the immediately invoked function expression. And there's a constructor function for this class, and it directly returns this constructor function from it. So people who know JavaScript well know this pattern, and that's what I meant with the clean output. You have a very nice syntax here, but in the end, it outputs an idiomatic JavaScript way of encoding classes. So you can instantiate it, which is just the same on both sides. And the nice thing about classes in TypeScript is that you can also add access modifiers on them. So I can say this has to be private. And as you can see, it now disallows me from actually reaching into to those members. The funny thing is that on the output side, there's really no difference. There's even no mention yet of the artist and the tickets properties. That only starts happening when I assign values to this artist. So let's say we have a string here. Then you can see in this constructor function, it will be initialized. So going by a more Java-like pattern, you can also add a constructor to this class and say, okay, I get a artist of type string, there you go, and tickets of type number. And in this case, I'm going to assign those. So this artist is artist, and this tickets is tickets. But since you do this a lot, it's also possible to use a shorthand notation for this. So what you can do is you can actually remove those members here and remove those assignments and say, okay, just add the modifiers here, which means that, and let me make it public for now, so the assignment still goes right, public tickets. And it means that we get this assignment for free. So it's a shorthand notation to sort of create a value class like this. And of course, we still need to move this into the constructor because it has to get two parameters unless we give it a default value, which I haven't. So there we go. Now classes cannot just have members, they can also have methods. So you could, for example, say I want to have a method by tickets. And again, these can be private, protected, or public, but the default is public. So by tickets, amount of type number. And you would have your body here, and you can just access this.tickets to decrease or whatever. I'm not going to code it out now. So that's a way to create member methods on these classes. You can also have static values. So I'm going to say static max tickets is 100. And as you can see, something interesting happens. Is that this max tickets, this static, is put directly as a property on the constructor function instead of on the instance that's being created. So that's of course the difference between a static and an instance member. One slight difference between Java and TypeScript is that to access the static here, we have to explicitly use the class name. So this is legal TypeScript. If you just refer directly to the max tickets, it doesn't know that it has to refer to the static. So that's a slight difference. One last thing I want to show about classes is that you can have inheritance. So we can say class rock concert extends concert. And we can add, for example, var goes to 11. And also create a separate constructor. Oh, what's going on here? This is, of course, a property, a class property, so it doesn't have the var keyword. And you can add methods here. You can override methods. You can access super methods by using the super modifier. But I have to do it inside of a method body. But anyway, there's full extension. As you can see, in this case, when you use classes, it's not just about getting help from the compiler, but it's also about code reduction. What we have here is a fairly readable class with a static and a constructor and a method. And what we get here is a bit less readable encoding of this class in the JavaScript. And again, if you look at the extended version, it uses a extends method, which, by the way, is one of the very few times that the TypeScript compiler inserts code into your code that you didn't write yourself. So it uses this utility function to extend constructor functions in the JavaScript side. So all in all, this is really a much nicer way to work with classes, of course, than using this widely popular encoding in JavaScript. Okay, I'm going to switch back to the slides again. Are there any questions, by the way, about classes? No? Okay. So another question that you can ask yourself is, that's very nice. I can write TypeScript and I can take my existing JavaScript and add type annotations and get better error detection, etc. But how do you actually integrate with existing libraries and existing JavaScript code? So the compiler won't know anything about that, right? And there's several things that are in the TypeScript language that help with that. And one of those is type definitions. So what you could do, and I'll show an example later, is that you can say, okay, this library introduces a new global variable, for example, the $sign of Jquery. I'm just going to ambiently declare it. This is a different keyword. It says ambient var is $, and then you have to give some type. But of course, yeah, you don't really know how to describe the type of Jquery, the Jquery object. So that's sort of a pity if you have to just say, okay, it's type any, and then you don't get any help anymore with when using a Jquery. So there's the possibility to use type definitions. And as luck would have it, there are many, many people who've created type definitions for you to use, and it's in a repository called Definitely Typed. And what you would typically do if you have an external JavaScript library is that you would look in this repository and see if there's a type definition available, and then use that to sort of import a type for this external library and use it. And I'll show an example later. Effectively, what you get from the TypeScript compiler itself is already a type definition file. It's called lib.d.ts, and it contains all the details about what is available in a JavaScript runtime. So the JSON.example that I gave in the document, is all those definitions are in the lib.d.ts definition file. And you can even use the type definition format to achieve separate compilation for your own project as well, because you can also instruct the compiler to emit type declarations, sort of for the code that you've written. And then when people want to program to your library, they can use this type definition instead of having to link to your source code. It's sort of similar to header files in C, but another thing that's really important, at least to us, for using TypeScript is that you have the concept of modules. And modules help separate namespaces and help make dependencies between different parts of a code explicit. So there are two different mechanisms that you can leverage in TypeScript to use modules. They have so-called internal modules, which are usable without any third-party support. They're just ultimately a way of creating namespaces on top of the JavaScript global object. And you can use so-called external modules, and those are modules that compile down to modules that can be read by, for example, an asynchronous method definition, module definition loader, like require.js, or a Node.js module that can be that's the common JS format, and those can be used very easily in a Node system. So there's a choice you have to make here, whether you're going to use an external module system or just rely on the namespacing solution. So with TypeScript 1.5 and going on, there will also be support for native JavaScript modules that are coming in the next version of JavaScript, which is of course the best of both worlds, because you get strong module separation, but you don't need an external library or tool anymore to use and load those modules. So with that, I'm going to my last demo, which is a demo I'm going to do in IntelliJ, and it's a somewhat larger application. What we're going to do is build a very, very small single-page application just to show how everything comes together. And I'm going to open it for you. As you can see, it's empty still. So what we want here is that we do a backend call to get some concerts that you can book. And I want to plot them here. And if you click on one of the concerts, you will get a nice picture and a order form for tickets. Right? So very simple, but it will show some of the concepts that we've talked about. And I'm going to use Jquery for any DOM manipulation, just so you can see how you can integrate with an external library. So the first thing that I'm going to do is we're going to set this up in a sort of a model view controller way. So I'm going to create a service. Let's call it the concert service.ts. And I'm going to give this its own module, which means that unless I say so, nothing that is defined inside this module will be visible to the outside world. So in this case, I want to have a concert service, which is going to be a class that exposes the methods to do the backend calls. And I want this to be available to the outside world. I want the controller to instantiate the service, so I'm going to say I'm going to export from this module a class called concert service. And of course, a class is nothing without methods, so I'm going to define first the getConcerts method. And then the first question already arises, okay, what's going to be the return type of this function? So for this, I'm going to define some model classes in my concert module. Let's see, there it is. And actually, I'm going to define interfaces instead of classes because it will just be JSON objects that I get back. So this is the pattern that I talked about. I have a concert summary, which is really brief, just an ID and an artist. And I have an interface that extends this and adds the price and the image URL and the description. So quite naively, we could say that this getConcerts returns an array of concert summaries. So let's do that. And let's for now return null, otherwise the compiler won't like it. And let's try and see how we can get a backend call to work. So I would like to use Jquery for this, and Jquery has this nice method, getJSON. But as you can see, if I'm going to do it like this, there's no completion support, and it says, okay, I cannot find the name $, because it doesn't exist. So what can we do to integrate with an external library? Because we know it will be available, because we include it here. It's just that the TypeScript compiler doesn't know it yet. So what you could do is you could say, okay, I'm going to declare a variable of $, and give it some type. But again, yeah, how are we going to describe the type of the Jquery object? I don't know. I mean, this works. It won't complain anymore, but it doesn't help me because it doesn't know about any of the methods that are on the Jquery object. So what we're going to do here is we're going to download the type definition for Jquery, and we're going to use that. And for that, I can use a nice little tool called TSD, TypeScript Definition Manager. And I can query the repository and say I want to install the type definition for Jquery. So there we go. And it has installed a file, jquery.d.ts, which is a type definition file. So as you can see, it appeared here as well, and we're going to use that. So how do we do that? Well, for that, we need to reference this module that defines the typings inside of this file, and we can use a so-called reference directive for that. And then we say, okay, we're going to use jquery.d.ts, and it should pick up this reference anytime now. Yeah, there it goes. And actually, we get completion now because it knows about the type of this $. It knows that there is something like $, because I included this type definition, which also has the ambient declaration of the $. So I can see with full type signatures what's available on the Jquery object. So let's say I want to do getJSON, because that's what I want. And I'm going to just load a simple JSON file, which is here in the data directory, and which is also served. So nothing fancy. And how about we return that because we want to have this list of concerts, right? Well, again, the compiler complains, and it says, and rightly so, it says, okay, you're returning something of type Jquery XHR, and that's not compatible with concert summary array. So let's look at the definition of this method. At least the type definition, because it's just type definitions that are in the file that I just downloaded, not implementation. And then we can see that the getJSON method with the string URL and an optional success callback, which we don't use yet, returns something of type jquery.xhr. So what's that? So let's try and see if we can click through on that. And you can see you can really navigate through a library, which is really great in my opinion, and see what's it all about. And we can say that, see that in this type definition it says, okay, Jquery XHR extends XML HTTP request and a Jquery promise of something. Well, I can work with that. I can return a promise for my service method and use that as a basis. So instead, what I'm going to do is I'm going to say, okay, this is not just a concept summary array, but it's a Jquery promise, which in it has a concept summary, hopefully. So let's see if we can get that to work. I'm going to just instantiate this class just for testing. And as you can see, I have to prefix this class name with the module because it's in this namespace. And I'm going to call getConcerts on it. And a promise is fulfilled asynchronously, so we have to provide a callback, which in Jquery is the then function, which gives us the concerts. And I'm going to introduce a little new trick that is also part of TypeScript and also part of the next version of JavaScript, which is so-called fat arrow functions, which are just a nice, concise syntax with a slightly different semantics than normal anonymous functions in JavaScript, but I won't go too deep into that because of time. And these concerts, we're going to just log them to the console, see that it works. We still need to add, of course, our JavaScript file to our index. So let's do that. Let's add the concertservice.js. Oh, made a little mistake here. We're not going to log console concerts. That's it. And let's try again. That's better. So we got two objects back, one with artist Sting and ID1, and Aerosmith with ID2. So now all I need to do is somehow render this in the UI. So for that, I'm going to remove this because we don't need it anymore, and I'm going to create a new file called concert controller. Which is again in its own module, just to create nice separated namespaces. And in this module, we're going to instantiate the concert service. And note, I don't export this. This is private to my module. I don't want this to be accessible from the outside. And this is of type concert.concertService. And we're just going to do a new concert service, just like that. However, it complains and says, okay, I don't know anything about a module called concert, which is right because I haven't been explicit about my dependency from this module to a different module. So again, I'm going to create a reference to, in this case, the concert service module, the file that contains the concert service module. And that should appease the TypeScript compiler. And indeed, we can now use this concert service. So what we're going to do is we're going to use Jquery again, which I can use transitively because I imported this concert service. So I say the document.ready, and we give it a callback again with this nice arrow function syntax. And what we're going to do in this callback is just call concert service .get concerts. Then we need to do the same trick with the callback again, with the then function, and then we have the concerts available, and we need to do something with it. In this case, I want to create a view module that can somehow render the concerts, just to keep it nicely separated. There we go. And of course, there's no concert view yet, because we still need to create it. So I'm going to create a reference, even though it's not there yet. Concert view.ts. And let's create a file. And we're going to export, in this case, a variable called render concerts, which is actually a function. And that's perfectly fine in JavaScript and in TypeScript. And it takes something of type concert.concertSummary. And we need to do something with it. And this is not quite right. It's concerts, and it's concert summary array. And again, we have to be explicit about our dependencies. But in this case, I'm going to say I depend on the concert controller, which will give me transitive access to the concert service as well. So we get an array here, so concerts.forEach. We need to do something with the concert. And what I'm going to do is use some Jquery magic to append it to the DOM, which is just plain Jquery code, nothing special going on here. So we need to update our index with the newly created files. We now have a view and a controller as well. There we go. And if everything goes according to plan, we have now these two concepts that we had from the backend. So still, one last step that we need to do. When you click on something, we want it to be shown here. So how can we do that? Well, let's start at the view, because we want to add something, a click handler to this concert node. So let's do that. We use the on method, and again, I get full completion of whatever is available on this concert node. That's a jQuery return thing. And we're going to do on click. And then we need our callback, which contains an event, which is of type jQuery event object. And I knew that from the top of my head, but you can also look it up, of course, in the type definition file. And once we get this object, we need to extract the ID from it. So if our ID is event dot, what's it called? Delegate targets. So again, auto completion for the win. Get the attribute ID from this node, read back, and we're going to delegate everything else to the controller again. So we're going to say concert controller dot select concert. Select this ID. Now, of course, we need to implement this method, because it will already complain there's no select concert, which is true. So we're going to quickly create that. Export var select concert, which is a function taking an ID of type string. And we're going to do something. Namely, we're going to do a backend call, get concert, which we haven't written yet, but we will shortly, for this ID. And then we're going to we're going to render again. So concert view dot render concert. And look, I'm just going to pass a function reference here, which we haven't created yet. And I could even do the same here. It's we're in this callback, we're just passing this parameter to this function call, and you can really nicely replace that by just passing this function without its argument, and it will be applied automatically, like this. Okay, so still two things we need to do. In the concert service, we need to add the get single concert. So I'm going to cheat a little bit and copy paste this. And in this case, we get concert with an ID of type string, and it returns a concert instead of a concert summary. And we're going to load a file given the ID. So there we go, simple enough. And we still need to do the rendering in the view, for which I'm going to expose another method in the view, var render concert, and it gets a concert of type concert module concert interface. And luckily I prepared the rendering code for that as well. So there we go. And let's see if there's anything left to do. Obviously we need to do the get concert on the same class instead of creating the same named class with a different method. That's my bad. So there we go. And again, compile time problem, not a runtime error that I got. I could fix it before I could even run the code. So let's try it again, and if we click it, yay, there we go. There's our nice picture and order form. So this is just a bit more of a complete example of how to work with TypeScript and various features and how to integrate a different library like jQuery as well. So what we actually use in production is TypeScript together with AngularJS and using the external modules, using require.js. And we really, really like it. And I think it only gets better with the support for the ES6 modules. And since Angular is also moving towards TypeScript, at least that's the current plan, I think things will get even more and better integrated. So TypeScript really is one of the less invasive options if you look at the alternatives to JavaScript. And it allowed us for a very nice and gradual migration path from our JavaScript code base to TypeScript. As you can see, there's lots of features that you can use directly, and some of the features might be only usable after you've gained some more experience using TypeScript. But that's okay. You just use whatever you need and what you want. There are downsides, of course, because it's not a complete clean break from JavaScript. A lot of quirks that are still available to you also in TypeScript, like the whole equality thing with the triple equals and double equals, etc. And that's all not going away if you're going to use TypeScript. So even though it helps us, it doesn't completely take away all the pain. It also introduces a compile step into your flow. Practically speaking, that's not really a big problem for us because we already had some other compile steps also for CSS compilation from Sass to CSS, etc. So it's just one more step for us. The compiler used to be sort of slowish, but they did quite some rewriting, and it's okay now. And there's no external module syntax that's ES6 compatible yet, but I'm really looking forward to that, and that's coming. And if you look at the tooling, we've seen IntelliJ, you've seen the Playground. There's also a plugin for Atom, the text editor for TypeScript. So there's lots of tooling and lots of activity. But it is often the case that the tooling from Microsoft is faster to update to the latest features than the third-party tooling. So for us, it has been a high value and low cost improvement over JavaScript, which gives us more safety and more modularity in our front end as well. So it's highly recommended. So if you want to look at the code that I've used and created, that's at that URL. And if you just want to learn TypeScript, there's a fairly nice handbook at the TypeScript website. And with that, I would like to close it down for now. Thank you for your time. If you have any questions, feel free to ask, and we can discuss. Thank you.